Good morning. Today we're going to show you how to use the AXXAIR CC222 pipe cutting system. Now the unique thing about this is this setup video will actually work for all of the CC range. If you have a 4-inch, a 6-inch, an 8-inch saw like this, even up to the 12 or 16-inch saw, all of these instructions would be the same. We have a couple of options shown on this system. So walking back this direction, we actually have our pipe feed table. If you look here, there's a bolt pattern. On this bolt pattern, we actually have a connecting piece. We don't have it in here because we're just testing in our shop right now, but that would actually connect these and make them remain in line with each other. That bolt pattern connects on both sides. There's female threads there. You simply bolt in that connector, and then you know that your feed table is in line. So what we have here is a piece of 6-inch Schedule 10 stainless. This allows you to put up to a 20-foot stick on this feed table, and you can feed it right through the saw. If you look over here, we actually have another one of these feed tables. You would normally set it on this side. Again, there's a bolt pattern to connect with a spacer, so that you can feed longer cuts all the way through and not have to worry about supporting it on both sides of the cut. It's very important to remember when you're cutting with an AXXAIR saw that you support both sides of the cut. We have to support the stock piece if it's long, and we also need to support the drop piece so that we don't have things breaking away while they're in the middle of the cut. So if you step on around here, I'll walk you through the basic setup of the saw and how we align the blade to the material. Now again, this is 6-inch Schedule 10. So what I can do with this wheel right here is I can adjust the saw up and down to match the center line of the tube, so that I can make sure I have a nice clean pass through for the material. And then I simply take this clamp and clamp the tube in place. So I've adjusted the height here for the center line of the saw, and then I clamp the tube or the pipe using this clamp. Now to set my blade depth, I put my motor in the cutting position. So if you look here, this is where this pin resides. I drop it into that position, and that would be in the fully engaged or cutting position. And then I simply bring the blade up so that I can physically see that I'm going to have 3 or 4 teeth penetrating through the ID of the tube. I then pull that pin back and drop the blade back out of position. Now I'm ready from a cutting perspective to go ahead and make a cut. So what I'm going to do is I'm going to feed just a little bit of tube through. Now then, one of the unique things on the AXXAIR system is we have this swivel. So as this blade rotates around the pipe, and that's why we call it an orbital saw, the saw blade actually rotates around the pipe. While it does this, we have this swivel so we don't have to worry about our cable getting bound up. One of the unique things on this particular saw is we have an automatic feed system attached. So if you come around to this side, the first thing we're going to do is we're going to show you an option that is on this saw that may be something you would want to employ as well. This is our automatic rotation. This really brings to light a lot of the benefits of the AXXAIR system, because this AXXAIR system is not just a cutting system, it's a beveling system, and it's a welding system as well. So if you'll step on in here, we'll turn this on and let you see what the setup function looks like. So we've plugged it in, and it's telling us to hit the start button. And I'm going to go into the settings so you can see how to set this up. So first we would tell it that we're using the saw that we're using. And so this one happens to be a CC222. So I pick that. And the motor we're using is an FS19. I can use different motors, but the one that we're using again is an FS19. We've got it set for inches, and we can pick the language as well. Now I go into my cutting, but I want you to notice that there's cutting, beveling, and welding settings that we can set. But since we're just cutting with this one, we're just going to show you this. So our OD of our pipe or tube is what we're going to do next. And that is going to be 6-inch pipe. So that's 6.625. And then we're going to want to cut at about 3 inches a minute. So now we set our speed on our rotation of the blade around the pipe, and we've also set the OD of the pipe that we're cutting. It's also important that we have the right blade. So what I want to do is I want to show you a couple of options. This is a carbide tooth blade. If we were cutting carbon steel, we would want to use this because it gives the longest life and gives a really nice cut. But what we find on the carbide for cutting the stainless, it doesn't last as long as we would like. So we typically use a high-speed tool steel blade for the stainless. We have various different tooth pitches, and what that means is how many teeth per inch of circumference on that blade. Depending on your wall thickness would be the thing that would tell you what tooth pitch to buy for your particular application. Now then, I told you that this automatic rotation is an option. Every saw comes standard with this, which is a hand wheel rotation, and it simply bolts into the same place. So if you didn't have this, you would have a hand wheel rotation. And on the hand wheel rotation, we have the option of cutting and beveling because the motor rotates around the pipe or tube in a different direction for beveling than what it does for the cutting application. But since this one was ordered with automatic cutting, we're going to go ahead and demonstrate this so that you have that shown to you. Okay, so again, we've set our blade height. We've set the pierce height of our blade. So when we actuate this handle and we go all the way through and rest it in that position, it will have fully pierced the wall of the tube, and then we'll be ready to cut. So the other thing that we need to show you now is that there is a blade speed adjustment on this motor. So it has a rheostat on it at a speed of 1 to 6. Now we're cutting stainless, so my recommendation would be to cut it at the lowest setting on an FS19. An FS19 has a maximum blade speed of 270 RPM on the blade itself. If we go with an FS15, it has a 3-to-1 gear reducer put into this section here, so the maximum blade speed rotation is 90 RPM. So if we're using an FS19, we're going to want to turn that blade speed down quite a bit. You can hear that motor kick up. Now I'm going to turn that down. Now then, for the purpose of this video, we are not going to lubricate on this cut, but I would recommend using lubricant if you want to maximize blade life. Keeping in mind that you're cutting this so that you can weld, you may decide that buying blades is less expensive than having to remove lubricant. That's a user decision. We have clients who go both ways. Some will go ahead and lubricate and make sure they clean the parts well. Others will choose to buy more blades and not have to worry about that contaminant. So again, we fed the pipe through the saw and we're ready to go. The one thing I don't want to forget is I want to make sure I have my safety glasses on. So I'm going to put these on, set my glasses off here to the side, and now we're ready to cut. So I turn my blade on, and I engage that blade into the ID and get it locked into position. You can see here that we're piercing through the ID of the tube. If this were copper, if this were carbon steel, even if it's plastic, it doesn't really matter. The process is the same. Now over here, I am ready to go. So I simply hit the start button and it starts doing the rotation. We see on here a adjustment for speed if we wanted to cut faster. And then we also have a indicator of the amount of energy or torque that we're putting on that blade. As long as we're down here in the green area, we're okay. If I wanted to speed up, I can do that. Now we're at 4 inches a minute. If this starts getting up here in the yellow and the red, what that's telling me is my blade's getting dull, and I probably want to change that out. If we were cutting carbon steel or copper, we would dramatically increase this speed. By using this automatic rotation, I guarantee myself a couple of things. One, I'm not over torquing that blade. I'm not overworking it. I've got a nice consistent feed. I'm also not going to put my operator in a fatigue issue. There's no chips coming back at me. I can get away from the cutting area. Again, we'll see that swivel. Nice to have that functionality so that blade or that motor cable is not getting bound up. The other thing that's nice about this automatic rotation is this motor starts going downhill. Obviously, gravity would tend to want to make it speed up. You're going to hear that we don't have a change in speed there. It's very consistent. Again, I'm cutting without lubricant. So that will impact blade life, but I'm not introducing a coolant or an oil to that cut area, so I don't have to worry about that from a welding perspective. Again, that's a client decision, but it is my suggestion that it's cheaper to buy a new blade than it is to have a bad weld. So a lot of our clients will choose to cut this way, especially on stainless steel. We're finishing up that cut now. That cut's not hot. I'm going to set it off here to the side. Go ahead and disengage my motor and turn off that blade. It's going to rotate around to the home position, and then it's now set up ready for another cut. What I wanted to show you is the fit up you can expect off of the saw. These are two parts that we've cut. We've done no dressing to the end. And you can see that they fit up very nicely. The cut piece, you can see the finish on this. Very smooth. Again, there's been no post-cut addressing of this at all. The saw should cut you within a few thousandths of square. So if you're using this to prepare yourself for an orbital weld, whether it be sanitary tubing or Schedule 10 pipe like this for maybe a brewery application or a chemical application, you should be able to go directly from the saw to fit up your pipe and weld. In this video, we've shown you how to set this device, the auto rotation, for your particular saw, the motor, the OD, and the speed at which we're going to cut. We've shown you how to change the blade speed with the rheostat on the motor, and then we've shown you how to adjust both high and low for the center line on our cart here, our table, and we've shown you how the clamp works. The next video that we show you will be on how to change the blade on the motor. Okay, so now in this video, we're going to show you how you would change out the blade on that motor. Again, we showed you on here that if that graph on the amount of power it's taking to, or the wattage that it's taking to drive that motor around, it kind of lets us know if our blade's getting dull. You can also have a look at the cut itself, if the chips are coming off and they're discolored, or if the blade and the motor seem from a audio perspective or from a sound perspective, they seem to be a little bit labored and it's struggling a little bit. It's probably because your blade's dull and we need to change that out. It's a very simple process. So we take an Allen wrench and we simply loosen these two tabs that hold the motor in place. AXXAIR is unique in this design. It's logical to assume that repairs will take place predominantly on the motor because that's where most of your moving parts are. So what AXXAIR did that was really ingenious is they made the motor something very easily to remove. So as you can see right here, I simply remove that motor by loosening those two tabs and pulling that out. I'm going to unplug this so we don't have to worry about this being under power while we're doing it. So what we have here, this is the nut that holds this in place. And if you'll notice right here, we have in this washer, we have a hole where there's a pin that comes through. That is effectively our fuse. If that pin breaks, it's because this blade's gotten dull and now it's having to work a little harder and we're putting too much torque on it. So what I'm going to do is I put this motor on its side and then I simply give it a shock to outrun the gearing. And I take the blade off, and here is that pin that I was talking about. So that pin slides through the hole that's in the blade. You can see that hole in the blade. And now what I'm going to do is I'm going to brush the chips off of this so that we don't have any chips in our blade engagement area. Always want to have a clean blade. Make sure that we don't have any chips that are going to be between that washer and the blade itself. We want to make sure that this housing here is really clean. Now, one thing that's also unique about AXXAIR is this is the side that would go toward the clamp. There's another place I can put a blade, which is away from the clamp. What that is used for is, let's say that we were cutting off an elbow or we were cutting off a ferrule, and we had some protrusion that would keep us from getting in there. This allows us to cut away from the clamp so we can cut off fittings and things of that sort. So they were really thorough in their design on this. They did a great job. So clean that washer off, get it ready to go. So when we put a blade on this, we always want the writing to go toward the outside, okay? So the outside is this direction. So the writing on this blade, I would put down. So when I'm looking at the blade from this perspective, I don't see any of the writing. I then take that washer that has the pin, line it up with that hole, and lock it in place, just like that. Then I take that nut, put it back on, and again, I'm gonna give it a good shock to outrun that gearing, and that's really all I need to put that back on. Now I simply take my brush and I'm gonna clean those chips out of that area as well. Again, we don't want those chips getting in the way. Put the motor back in its home position and tighten these two tabs. And these just need to be snug. You don't have to get overly aggressive with how tight that is. But now we've changed out our blade and we're ready to go back to cutting. Thank you for watching this video.